of the team who's going to lead this. So Stephanie?
Hi, everybody. I'm Stephanie Casey. I'm a professor at Eastern Michigan University, and I'm one of the PIs on the grant. In particular, I focus on the writing of the statistics materials and the professional development side.
And I'm Allison Lishka. I'm at Middle Tennessee State University, and I am one of the PIs on the modules team. I was one of the writers of the geometry materials, and I work with the research team for the project as well.
And I also see that we have Andrew, who is on the stats writing team. I haven't looked through the participant list to see if we have any other modules folks. I don't know if you've scrolled through yet or not, but welcome, Andrew. All right, so let's jump right to it. Here's a preview of our hour together. We'll start by sharing what the project is all about, and then we'll discuss the principles that we use to design the materials and share a few activities with you. We'll pivot to share results from research that we did during the project. And finally, we'll wrap up by explaining the online professional development supports that we have put in place for modules. And then that's when we'll take your questions. So along the way, we encourage you, please put any questions that you have into the chat, and we'll do our best to address them. So modules. We began as a working group within the Mathematics Teacher Education Partnership, or MTEP. MTEP was formed to address a downward cycle in math teacher preparation. This will probably sound familiar to you. We start with the reality that many K-12 students don't learn challenging mathematics. And then those students enter college underprepared for math, and many of the best prepared students don't actually go into teaching. But then math courses that are taken by secondary teachers often don't help them develop the math knowledge that they need to do the work of teaching. So those same prospective teachers are too often apprenticed then in classrooms with teachers who themselves know little mathematics. And then when they do become teachers, they're left to fend for themselves in continuing their own professional mathematical education. And you can see where this is going if you haven't seen it already. This results in too many talented math teachers getting frustrated and leaving the field, thus reinforcing the problem that, back to the top, many K-12 students do not learn challenging mathematics. So this is a big problem. And it's a problem that MTEP was created not only to tackle, but to actually reverse. And modules was tasked to address this piece, that many math courses taken by secondary teachers often don't develop the mathematical knowledge necessary for doing the work of teaching. We want, as the modules project, to reverse this part so that secondary teachers have the math knowledge they need so that they can be excellent teachers. Other parts of MTEP work to reverse other pieces of the cycle, and we just don't have the time to discuss all of this, unfortunately. But of course, the ultimate goal is for more K-12 students to have opportunities to learn challenging math. So let's move a little bit deeper into the modules project. Most central to our work is that we developed semester-long curriculum materials in each of these areas: algebra, geometry, statistics, and mathematical modeling. Our explicit goal is to develop secondary teachers' math and stats knowledge for teaching as they learn content in university math and stat courses. To support this goal, we have instructor versions of our materials and a Canvas learning site that is a place where professors who are teaching with the modules materials can go. A related goal is to conduct research that advances the field's understanding of the development of MKT. And this is all what we're going to get into today. So on the whole, our 6-year-long project has seen 65 faculty pilot the materials at over 50 universities in the US and Canada, and has impacted nearly 1,000 prospective teachers. Throughout the project, we have worked to continuously improve the materials after receiving feedback from piloters and students at least once a year, if not more. We've designed modules materials so instructors can go deep with content in their upper level math and stat courses. As teachers go on this deep dive, we want them to first walk away with advanced perspectives on math content related to their secondary teaching, but then second, We want them to fully engage in the process of doing mathematics and statistics themselves as part of a learning community. Our second design principle, as we put together the module's materials, involved using several types of assessments that give prospective teachers a chance to apply their math and stat knowledge to scenarios set specifically in the work of teaching. So prospective teachers analyze student work and they plan how they'll respond to students as if they were actually their teachers. They also plan whole class discussions that are centered on real student work that we provide in the teaching scenarios in the materials themselves. As I mentioned before, throughout the module's materials, we provide supports for instructors. One of the goals of this support is to help instructors teach the course using research-supported instructional practices. The materials also include supports for prospective teachers so that they can develop expertise in teaching with these same prioritized instructional practices. So you might be wondering, what exactly are these prioritized instructional practices? So here they are. The practices that our materials prioritize have a strong research base, and they hold that first, instruction should bring out student understandings of content. And once student understandings are on the table, students should have an opportunity to offer explanations, justifications, and create and use representations to communicate their understandings to others. So our materials make space for that in the instruction. And then second, instruction should generate questions and discussions in ways that leverage student understandings to promote students exploring their conjectures and justifications. So our instructor materials support college professors in using these practices throughout the course, and then assignments in the materials give prospective teachers an opportunity to practice using these very same instructional techniques as well. Our final design principle is related to equity and social justice. So the materials and the modeling and the statistics materials are unique in that they both will explore data and context from problematic social situations. And they also consider how mathematical models and data analysis can be used to shed light on things that may improve the lives of people who are in those problematic contexts. In our work together, we've created a useful way of conceptualizing how the modeling cycle and the statistical analysis cycle interact with one way of thinking about social justice. So we won't be able to get into all the specifics here, but there was one important thing that we wanted you to notice as a key takeaway. And to do that, we'll start at the bottom. So work in social justice issues often begins with a specific situation. So in a response to an unjust situation, this can lead to increased civic awareness and a sense of action that addresses a larger, broader social justice issue. And this can in turn have an impact on equity and justice for other related specific situations in this cycle. Now, specific contextualized situations are the starting points also of the modeling cycle and the statistical analysis cycle. And you'll notice, so a specific situation can start a statistics investigation cycle or a modeling cycle, and then we'll go through those pieces, but then related at the top, at some point, both of those cycles report out, and that can inform another cycle in the social justice that's spurned by a specific situation again. So whether you use the modeling or the statistics materials alone, or if you use them both, there's really nice opportunities when teaching with the modules materials to engage in social justice issues in the classroom in a way that makes sense and that we found that our prospective teachers really enjoy and learn from. So our materials also attend to equity and justice through our use of equity-based teaching practices while we're teaching with the materials in our university mathematics courses. So here's a list of the equity-based teaching practices, and I'll just briefly mention each one and how the modules materials is connected to them. So we go deep with mathematics by focusing our materials on student understanding, pre-service teacher understandings. The materials leverage multiple mathematical student competencies by making room for instructional practices that draw on student strengths. We affirm mathematics learners' identities by encouraging, supporting, and promoting student participation during class explorations. We challenge spaces of marginality by promoting teaching practices that embrace student competencies through the use of group work, class discussions, and projects. And then finally, we draw on multiple resources of knowledge by tapping into students' knowledge and experiences, both mathematically and more broadly in terms of culture, language, and peer groups, et cetera, as they learn in the course. So this is kind of like a really quick sprint overview of our materials. And I want to throw it to Stephanie to dig into some specific activities, but I just realized after we introduced ourselves, we wanted to learn a little bit about you all and where you come from. So Stephanie, do you still have that poll up? And we could just get a sense of who all is with us today. Awesome, thank you all. So Stephanie, it looks like we have about half of us are math teacher educators, about a third are mathematicians, and then a mixture of something else and some department chairs. So welcome everybody. We're so happy that you are with us and expressing interest in our materials. We look forward to conversing with you. All right, so I think Stephanie is going to dig into specific modules activities as we continue on.
Yeah, thanks everybody. Jeremy, you can go ahead and advance the slide. All right, so we're going to get a chance to preview a little bit from the statistics materials and the modeling materials. Of course, it's hard to pick just two examples that are going to try and illustrate everything, but we're going to do our best. Hopefully, they're going to make you really excited and want to see all of our materials at the end. So I'm going to start with the statistics one. It comes from our first unit, which is on exploratory data analysis. And it dives into the social justice issue regarding school funding. So we in particular chose this for our materials because this is an equitable issue that is certainly pertinent to teachers, and we felt that they would be not only really interested in thinking about data in this space, but also this is an area in which they could advocate for change in the future in their role as educators. So we dive into what's happened in Pennsylvania. Back in 2015, there was an effort to create a new fair share funding approach with the state level data, education funding, because many people felt that Pennsylvania's approach was unfair. And so a committee was put together and they came up with a new fair share funding formula, which is super complicated and we're not going to present right now, but it took into account all these things in the pink bubbles. So how many students were in a district? What's the median family income of that district? How much concentrated poverty exists in a district? What are some geographic factors like how sparse is the district, or like how spread out is it? So it would require more busing to get everybody to the schools, for example, and then a few other factors as well. In an ideal situation, all of the state's education funding would have gone through this funding formula, and out would have come how much each district would receive. Go ahead, Jeremy. However, in reality, when the recommendations came back from the fair share funding panel, what they actually decided to do in Pennsylvania was only put the 6% funding increase that was going to go into effect in the coming academic year through the fair share funding formula. The remaining 94% was going to be gone based on how much that district got in the past. So as a result, we have a data set that tells us how much a district would get if every dollar went through the fair share funding formula, and how much each district actually got. Because again, only 6% of that funding increase is what got put through the fair share funding formula. We also in this data set have information about lots of these demographics that are in the pink bubbles. So we know how these factors are playing out for each of these districts. So with that, go ahead, Jeremy. This is a graphic that the activity supports students in making. And what it is a scatter plot of the actual state funding per student on the vertical axis, the amount that a district would have gotten if all of the money was put through the FAIR formula funding on the horizontal axis, and then an overlaying of the line f of x equals x on it, which represents the idea that if you're on that line, the actual funding would be equal to the FAIR formula funding. And there is one dot or case for every district in the state of Pennsylvania. So students take some time to unpack this. They think about what it means to be on the line, what it means to be above the line, what it means to be below the line, which then leads to a very important contextual question, which is, which districts received less than their FAIR formula would have received and which districts got more? In other words, what characteristics of these districts could possibly help us predict which districts were getting more than the FAIR funding formula would have had them get and which would have them getting less. So there's, again, like I mentioned in this data set, lots of additional variables that they can examine and think about. And go ahead, Jeremy. Sorry, go ahead. Oh, I already said that. Go ahead. So these are just two of the variables, and we use the statistical program CODAP, for those of you that this may look familiar to. And so in CODAP, what you can do is overlay a third variable on top of your scatter plot, and it will color code the cases in that scatter plot, and you can see the legends there at the bottom. So these are just two of the additional demographic variables that are in this data set. One on the left is representing the median household income in that district, which you might recall was one of the pink bubbles for the FAIR formula funding. They thought that was important. The graph on the right shows the percentage of white students in the district. The higher the percentage, the greener the dots. So then the statistics materials have students really dive in and think and analyze about these multivariate graphical representations and think, what is this telling us? What is this helping us see? And I'll give you a moment to look at these plots and think about what are these showing you. I can see somebody wasn't too surprised by the results, that the percentage of white students in the district is a pretty high predictor of which districts are getting less than the FAIR funding formula would have them receiving. Students with fewer white students are getting less than the FAIR formula would have them get. And it is often surprising to students to see that median household income really isn't corresponding with that. It's, the distribution is about the same above and below the line. So we get an opportunity to not only dig into these data visualizations, but we also get a time to dig into this context and really think about this. And we follow this up by this idea for enacting change is to make a data-driven argument to someone who has the power to make this change, which is a state government official. So we ask our participants who use these materials to pretend they're writing a letter to a state government official about funding imbalances for schools. What data-driven things would you say? So we really think it is powerful to build up person's abilities to use data-driven advocacy. And this is one example of how we do this right at the beginning of our materials. So from here, I'm going to move into a really cool example from the modeling materials. So in those materials, they have a task called the Great Sioux Reservation task. And the context for this is as follows. The top map shows the boundary of the Great Sioux Reservation back in 1851. And the map at the bottom shows the change. You can still see the faint outline of what it was in 1851, but you can see the new reservation boundary that was put into place in 1877. So the modeling task really mathematizes this situation. It asks the modeling users to develop a procedure that can be used to approximate the area of the Great Sioux Reservation and use that to calculate the percentage in area reduction between 1851 and 1876. And it should be noted there is a legend on these maps so that they have that to go by. The participants are asked to describe their method for estimating the area based on the map images. So truly open-ended, leaving it up to the students to pick an approach that makes sense to them. Estimate the accuracy of their solution and describe changes they would make to improve the accuracy. And then develop an improved procedure based on your initial solution and your analysis of it. So in the next few slides, you're going to get to see a variety of approaches that users of the modeling materials have created. So one is that they create trapezoids to estimate the boundaries of the reservations at the 2 points in time and do a calculation of the area via the trapezoid area formula, and then just do a simple percent reduction. Another approach is they break it into composite shapes. So not just one shape, but they're breaking it down to a number of smaller shapes, and they find the area of each of those, sum those up, and therefore get a total land area estimate. Another approach taken by the users is to make a grid overlay on the map and estimate their area in that approach, coloring in squares that the reservation was in and partial squares, etc., to get a different estimate of how much land was there and what the reduction was. So this group got a reduction of 64%. You might have noticed the first group got a reduction of 57%. This group used functions to model the boundaries of the land in Desmos, and then used integrals in order to calculate the area between the different functions. So yet another approach. And the materials encourage the students to put their work on posters around the room, and then they do a gallery walk so that they are truly, coming up with their own approaches, then able to justify them and share their thoughts on those with their classmates. And then that can also inform that idea of how could you improve your initial approach to this. So I've shown you a lot of the mathematics of this task and what's happened, but there also in the materials is a lot of support and encouragement of thinking about the contextual issue of taking land from the Sioux Reservation over time and why that has happened, what is happening, how's our government treated Native Americans in this country, et cetera. So, like that model that Jeremy showed you before, there's a meaningful interaction with the setting, not only in the mathematical sense, but also in the equity social justice sense. So to see some of these things fit together, our goal is to develop our pre-service teachers' equity literacy. So like Jeremy mentioned, we are using equitable teaching practices, and in particular, these two prioritized instructional practices in our work. They also support the interrogation of social justice issues. And then again, in particular, we're focused on this in our math, modeling, and statistical materials. And then through this is helping us develop their equity literacy, their ability to recognize, respond, and redress biases, inequities, and oppressive ideologies, both in the immediate and the long term, by really thinking about root causes and how can you also change this in an educational setting. So working to cultivate and sustain bias-free, equitable, and anti-oppressive ideologies in teacher education, classrooms, and schools. All right, thanks for sticking with me through that. I'm going to turn it over to Allison.
So Stephanie just gave you some insight on the statistics and modeling materials. Remember, we also have materials for algebra and geometry. We are an NSF funded project, and so we've been gathering a lot of data about the use of our materials, and I'm going to share just a few things that we've learned from both the instructors and the prospective teachers who use our materials. So as a reminder, the research problem that we're addressing is the disconnect between upper level secondary math courses required for in the teacher preparation programs and their connection to the courses that teachers teach when they're in secondary settings. So what we have found, Jeremy, if you could go to the next slide. We have a lot of quotes from a lot of students. I'm not going to go through very many of them, but we have found that engaging with these modules materials has changed prospective teachers' views about that disconnect. And they do feel that there is a better connection, or there is a connection between these courses that they're taking using the modules materials and what they'll be teaching in the K-12 setting. So they found them to be valuable and useful. One student said, the instructor did a great job pushing us to talk and discuss each problem. Then looking back, you can see the results of those discussions. Being able to do that myself will be a massive help. So this is a student who has had the opportunity to engage in learning in using the practices that we are asking users of modules to use to implement. The PSMTs appreciated connecting the advanced mathematics to the work of teaching secondary mathematics. So this teacher is talking about videos. One of the types of assignments that we have in all of the materials asks the teachers to respond to student thinking in a video that they record of themselves talking as they would respond to the student. So they're supposed to act as though the student is listening and they're responding to the student based on work that they are given. So these videos we had to create where we looked at a student's answer, get them to think where they might come up with the answer on their own without giving them the answer, I found very beneficial and helpful. So no matter where they are in their preparation program, we're asking them to start thinking about how do you respond to student thinking using their thinking. Jeremy, if you could go to the next one. Our research results also show that there is a purposeful development of pedagogical content knowledge alongside subject matter knowledge. And I'll get to some of the evidence on that in a moment. And that the pedagogical methods used by the instructors teaching with the materials model equitable teaching practices, particularly the two instructional strategies that we focused on in the materials. So our research evidence of that, all of these things are, some of these things are on their way out in press. The Lie et al. Is a ZDM manuscript that's been accepted and is in final preparations now. So in that we report on measures of content knowledge. So we have a content knowledge and MKT assessment for each of the content areas. And we found that all of our PSMTs exhibited a mean increase in their MKT as measured by that pre and post assessment. We also found we used expectancy value as a framing for a way to think about the value of these materials. Expectancy refers to, Jeremy's going to help me out if I say this wrong. Expectancy relates to the expectation that you can carry out a particular practice, and value refers to whether or not they value that for their future teaching activities. And PSMTs in all content areas reported increased expectancy and value for carrying out the core teaching practices. The statistics materials have shown that they develop PSMT's equity literacy and critical statistical literacy. Stephanie and Andrew reported on that. And prospective teachers valued opportunities to apply their content knowledge explicitly to the work of teaching, and the materials emphasis on equitable teaching practices. We also have some results from the instructors who use the materials. We haven't done as much reporting on this yet, but those are in the works. Our instructors who have piloted the materials reported that their PSMTs were engaged in understanding and it improved their engagement and understanding in the mathematical concepts. They found the materials easy to use and they felt supported by the instructor materials and the online professional learning space. They appreciated the flexibility of the materials. Each content area has 3 modules meant to be used as a standalone module, and they can kind of be mixed and matched. Jeremy has used a mix of the algebra materials and the modeling materials for a course that we teach at MTSU. We've seen them used in methods courses or in content courses, so they can serve a variety of purposes. Our instructors reported that they gained content and pedagogical knowledge that improved their teaching, and that the materials supported them in using a pedagogical approach that they want their prospective teachers to use in their future classes. So at this point, Stephanie is going to switch us over, and she's going to give you a glimpse of what we have in the online Canvas community, which is where we house our professional learning materials. Give us just a moment while we switch over to that screen. While she's doing that, feel free to put any questions that you have in the chat. After she goes through this demo, we'll have an opportunity to answer some of your questions.
All right, so if you haven't gotten tired of hearing the modules word yet, modules is used at a meta level here. So this is the modules project, and the modules project has a Canvas support site for every content area. I'm going to show you the algebra one, but all of them look similar. And the Canvas site for the algebra materials, as for all of them, are organized into modules, which is the Canvas language as well. So this is the landing page when you get here. We have 4 main modules that we have created to support you as instructors. One is an introduction to the project. I'll go ahead and jump there first. You get an idea of what all is this project's about. We've got an awesome video that you get to hear Jeremy be like his sportscaster voice. It's great. So, you know, we get you to know more about the project. You're getting a very quick Cliff Notes version here, but you'll recognize a lot of these things that this is telling you about. Again, these highlighted instructional practices that we're going to focus on in our materials. We also then dive into the specifics of what's in the materials for this content area. So for algebra, we go into which each unit, which are called modules, covers. So for algebra, module 1 focuses on concepts of relations and functions. Module 2 focuses on numbers, looking from numbers to powers to logarithms, and in particular exponential relationships. And then module 3 is all about fields and polynomials. And this is true for every content area. It's divided into 3 units or modules, and each unit has explicit key concepts that it aims to develop in the pre-service teachers as they use the materials. We also just have, you know, some more details there, and then we get to a link where you can get to our materials. So our materials, big selling point, are free. They are free to you and they are free to your students. So we have 2 versions of the materials. One is an instructor version and one is a student version for each of the 3 units. So you follow this link and it takes you to a Google Drive folder where you can download those. So I'm going to go back home. That's the idea of all the content areas introduction to the modules project. Then there's 3 additional modules that are meant to help you as an instructor learn how to use these materials. So, you know, these materials we know do not look like your standard intro stats textbook or intro, you know, college geometry textbook. They have a lot of unique characteristics to them. So we want to make sure that you feel prepared and ready to use them. So these 3 modules called Learn About the Modules Materials, Learn About Teaching with the Modules Materials, and Connect and Discuss with the Modules Community are meant to help you really feel prepared and ready to use these materials. So I'm going to go to the modules view here to give you a sense of what is in these. So in the Learn About the Algebra modules, you're going to get more detailed stuff about what's in them. But what's awesome is we were able to get videos made where the authors of the algebra materials, and again, same for each content area, talk you through what this is about. So there's a video about the vision of the materials, 3 additional videos that go in depth into each of the 3 units or modules. And then as last video that talks to you about how assessment works with these materials, what are some teaching tips and logistics about suggestions about how to run the class. The next module here in our Canvas site is called Learn About Teaching with the Materials. And what's fantastic here is we, again, have more videos of people actually using the materials and then commentary about things that we hope you notice as you watch these videos. For example, there's this one about how do you facilitate engagement in a task from these materials. Again, these may feel very different to you. It's very much about active student learning. You're letting the students run with an idea and see where it takes them. So that may feel very different to you. It could be really helpful to you to see videos where instructors are actually doing this. And we've got, you know, the task that they're going to focus on. And then again, for every video, we follow that up with some commentary based on the questions that we're asking you to think about when you watch that video. So really meant to be helpful to you as you think about implementing these materials and helping you feel more comfortable in doing that. We've got some additional information about those key assessments that were mentioned before, the video simulation of practice and the written simulation of practice. So some detailed information about that. Also this idea about, you know, how can I implement these equitable teaching practices, more videos and support about that, and classroom culture you want to create to support implementation of those. And like I mentioned, finally, the last module is here to help you network with fellow instructors who are using the module's materials. So we know that it can take a village, and we want to support that through these Canvas materials that we have here. So this is the general outline of the Canvas materials that we have. They look very similar across all 4 content areas.
Jeremy,
turn it back.
Last slide back up. So if you are looking for how do we access the materials, you go to our webpage, www.modules2.com. At the top of that webpage, you will see a link to use our materials, and there's where you will fill out a form. And that is, we're just trying to track who gets access to the materials. It's completely free, like Stephanie said, but you do have to register with us. So once you've filled out that form, you'll get an email with the link to the Canvas page, which is where you can get to all of the information that Stephanie just shared with you. We also have a talking points document. Some of you may be in a department where you have to make an argument for using these materials. And I think either Stephanie or Jeremy is going to share a link to that talking points document. So what we've created on this document is just a list of support for you if you need to go talk to others in your department to encourage the use of these materials. So it includes some research foundations and other points that we've found helpful in convincing others to take up the use of these materials. And the last piece of information, we are in the final year of our grant, a no-cost extension. So we are making final revisions to the materials. I say final, but we'll probably have some other edits as we go along. But the revised editions of the materials will be available later this summer. And once those revised editions come out, we'll put a message in the Canvas page, and we'll probably have a press release saying the new materials are out, but you'll access them still through the Canvas page, just like you access them for the first time. So at this time, we